Mass and Energy Balance in Biosystem, Module 1, Segment 2, Variable Unit and Dimension. Previously, we have discussed about course overview. In this segment, we will discuss about variable units and dimension. In general, the ability to measure and quantify physical variables is critical to finding solutions. Examples of physical variable includes mass, length, temperature, and velocity. Measured physical variables are usually represented with a number or scalar value. These variables include length, mass, time, electric current, temperature, amount of substance, and luminous intensity. A unit is predetermined quantity of a particular variable that is defined by custom, convention, or law. A number without units is meaningless. A mistake that beginning engineers often make is to write variables without units. Such mistake leads to many mistakes and significant consequences. It is very important to highlight that experienced engineers rarely omit units. Measured physical variables are represented by a number and a unit. The two most commonly used systems are System and International Deunitized, SI or metric system. Second is British or English system. Engineers must be familiar with both systems. Unit conversion is a process by which the units associated with a physical variable are converted to another set of units by using conversion factors. To convert a quantity expressed in terms of one unit to its equivalent terms of another unit, multiply the given quantity by the conversion factor. Several prefixes for the SI system are tera, giga, mega, and etc. as shown in Table 1.2 as in the main textbook. Dimensional analysis is an algebraic tool engineers use to manipulate the units in a problem. Numerical values and their corresponding units may be added or subtracted only if the units are the same. Multiplication and division always combine numerical values and their corresponding units. Dimensionally homogeneous is when the dimension both at the right and left-hand side of the equation are the same. Dimensional analysis is a very powerful method for engineers to calculate quantities. Dimensional analysis can be used to determine the dimension of that quantity. Equation can be specified such that it is dimensionless. Dimensionless variable stands for a specific or succinctly represents a physical phenomenon such as Reynolds number. Physical variables can be categorized as extensive and intensive properties. Extensive properties depend on the size of the system or sample taken and can be counted such as mass, moles, volume, and etc. In contrast, intensive properties do not depend on the size of the system or sample taken, such as temperature, pressure, density, and etc. Physical variables are either scalar or vector quantities. Scalar quantities can be defined by a magnitude alone. A vector quantity must be defined by both magnitude and direction. The product of scalar quantity and the vector quantity is a vector that has the same direction of the original vector if the scalar is positive. Vectors can be multiplied in two different ways. The scalar product or the dot product of two vectors is a scalar quantity. The scalar product is also commutative. The vector product or the cross product of the two vectors is a vector quantity. Examples of scalar quantities include mass, length, time, temperature, pressure, and etc. Whereas vector quantities include force, velocity, acceleration, and linear momentum. For the next segment, we will discuss about important concepts related to mass and energy balance in biosystem. Until then, I am Yusuf from Institut Teknologi Bandung.